All right, today for Algebra 2 we have Chapter 5.3 and we're solving by factoring. All right, so to get us started, we've got 3 objectives today. The first one, we're going to solve quadratic equations using the zero product property. It's going to become our new best friend. 2, we're going to write a quadratic equation given its solutions. So we're going to write the quadratic equation. And 3, we're going to solve some real-world applications involving the quadratic equations. So some fun stuff coming up. All right, so first of all, the quadratic equation, okay, is any equation whose highest degree term, so if you think of x, x squared, x cubed, okay, is a squared term. So it is in this form we've been working on, ax squared plus bxy plus c, only this time we have equals 0. That's that standard form, okay? So we were just calling them quadratic trinomials. Now we're looking at the actual quadratic equation. So it has an equal sign and a number. If the trinomial can be factored, then it can be solved, okay? So if it can be factored, then it can be solved using the zero product property. All right, so the zero product property is over here. Okay, so if p times q equals 0, then p equals 0 or q equals 0. Let me erase that so you can see it a little better. So either p equals, it says 0 or q equals 0. So we're going to apply that idea to this. So let's look at example 1. I've actually already solved it all for you. We're just going to walk through and talk about it and what's happening to it. So in example 1, we have the quadratic equation, x squared plus 2x minus 24 equals 0. So we first, step 1, have to factor it just like we did the trinomials. Okay, so what's the product? Okay, negative 24. What are the factors of negative 24 that add to get me a positive 2? So positive 6 times negative 4 equals negative 24. Positive 6 plus a negative 4 equal a positive 2, which is what I'm going for. So 6 and negative 4 are my factors. So that's why I have x plus 6 and x minus 4. All right, now this is the new step. I'm going to set each of these factors equal to 0. So I have x plus 6 equals 0 and x minus 4 equals 0. Step 3, I solve it. So subtract 6 and I get x equals negative 6, add 4, and I get x equals 4. I'm done. I've solved it. Okay. I did show you how to check this one. There hasn't really been anything to check necessarily with the trinomials, except to make sure we get that trinomial out when we multiply the two binomials. In this case, we can actually plug in the x value and make sure. So if we plug in negative 6 for x everywhere, so we took it back up to the quadratic, it should equal 0. So we work it all out and we get, hey, 0 equals 0. So check, this one works. We do the same thing for the 4. We plug 4 in for x, so 4 squared plus 2 times 4 minus 24. We do all the work and we get 0 equals 0. Check. Those are the two solutions, negative 6 and 4. Okay, are how we solve this quadratic equation. Those are the values of x. All right, so let's look at the steps to do this. We kind of just walked through them quickly, but let's look at them a little more in depth. So solving quadratic equations by factoring. So the first thing, number 1, write the equation in standard form. So ax squared plus bx plus c equals 0. Step 2, factor the polynomial. Step 3, apply that zero product property, which really means you're going to set each factor that contains a variable equal to 0. So that was when we said, hey, x plus 6 equals 0 and x minus 4 equals 0. That was that step. And then 4, you're going to solve the resulting equations. All right. So let's flip over and try to do that. Okay, so here we are with example 2. We've got 2 examples here we're going to solve. The answers up in the little corner, or the numbers up in the little corner, are your answers, what we should get when we get done. All right, so first of all, let's factor. Okay, that first step was to factor. All right, so if we notice this first one, right, we have a 3 and, well, let me go back. Rewind a little bit. All right, our standard form was ax squared plus bx plus c equals 0. We have equals negative 11x. That's problematic. Okay, we need to move that to the other side. So we're going to add 11x. Okay, and then we want it in the standard form. So we're going to write 3x squared plus 11x, then plus 6. So it's in standard form. And negative 11 plus 11 equals 0. So now we have it in standard form. And now we can solve. Okay, so now we have an a value of 3 and a c value of 6. So 3 times 6 equals 18. What are the factors of 18 that are going to get me 11? Okay, because we got to get this positive 11 here. Well, I know that 2 times 9 is 18, and 2 plus 9 equals 11. So that's how I'm going to split that one up. So I'm going to have 3x squared plus, I'm going to put the 9x here because 3 and 9 have a common factor. And then I'm going to do plus the 2x plus 6 equals 0. You can put them in whatever order you want. I chose to put the 9 first because 3 and 9 have common factors. Okay, then we do the grouping. So we group the first 2 terms and the second 2 terms, just like we did previously. So we can factor a 3x out of this first one. So 3x squared divided by 3x is going to give me x, plus 9x divided by 3x is going to give me 3. Okay, out of the next one, I've got positive 2x plus 6, so I'm going to factor out a positive 2. 2x divided by 2 is x, plus 6 divided by 2 is 3. All right, and this all equals 0 still. All right, then I have that common binomial, so I can factor that out. Let's pull out the x plus 3, and what we have left is the 3x plus 2 equals 0. All right. So all that is that step 2 of factoring in. Okay, now we need to set each of these equal to 0. So we're going to have x plus 3 equals 0, and 3x plus 2 equals 0. And then we solve. Subtract 3 on this one, so x equals negative 3. On this one, we're going to subtract 2. So we have 3x equals negative 2 divided by 3. X equals negative 2/3. Okay, so if we go up here and check, we got negative 3 and negative 2/3. So we did all the right stuff. Solving quadratics is going to be a big part of the rest of this chapter, but also the rest of the year. It's one of those things we'll keep coming back to. Okay. All right, so let's look at the other one, or the next one. 6x squared equals 8x. Okay, so we kind of have that same thing. We have our equals and an 8x. We don't want that. Okay, so we're going to subtract 8x from both sides, which will leave us with 6x squared minus 8x equals 0. Okay. So what do you see there? All right, we can go ahead and factor everything out. 6 and 8, what do they have in common? A 2, okay. So we'll take a 2 out, and then we have 3x squared minus 4x equals 0. Okay, we could have taken an x out, couldn't we have? A 2x. So let's do that. So let's get in there and take out the 2x. So this will leave us with 3x minus 4 equals 0. All right. Okay, so then if you remember, it said any in those steps, okay, on the front side, it said we had to set each part that had a variable in it. So each of these we are going to set equal to 0. So we're going to have 2x equals 0, and we're going to have 3x minus 4 equals 0. So this one we divide by 2, x equals 0. Okay, again, if we look, we've got that one. On the next one, we're going to add 4. So 3x equals 4. Divide by 3. X equals 4 thirds. And that's the other solution there. Okay, so we have to get it in the standard form. The big part of that is that it has to be equal to 0, right? We have to have equals 0. Otherwise, all of our work will be useless. All right, great work so far. Let's look at the next section. In this next section, we're going to be writing the equation. Okay, to find a quadratic equation, we're going to reverse the steps. So we're going to write each solution as a linear equation. All right, so write each solution as a linear equation. So ax plus b equals 0. Then we're going to use the multiplication property of equality to form a quadratic equation, and then we get to FOIL. So let's look at example 4. Again, it's kind of been done for us. We just didn't, or I've done part of it for us to get us through there. So we write a standard form equation, quadratic equation, whose solutions are -1/2 and 3. So step 1 says write each solution as a linear equation. So to do that, I have x equals -1/2 or x equals 3. Wrote the equation. Okay. And now what I need to get it into this linear equation form, that ax plus b equals 0, which means I have to undo what was being done. So in this case, we had -1 divided by 2. So I multiplied by 2 first to get 2x equals -1. And then we added 1 to both sides. So now I have 2x plus 1 equals 0. So this is good stuff right there. On the other one, x equals 3. It's a little bit easier. We just had to subtract 3 from both sides. So then I have x minus 3 equals 0. Now I've got that into that linear equation form. Step 2 says use that multiplication property, okay, of equality to form a quadratic equation. So I put both of those in this binomial form. So the quantity 2x plus 1, which came from here, times the quantity x minus 3 equals 0. And then step 3, I need to FOIL those. So let's do that. So first, 2x times x is, good, 2x squared. Outside, 2x times -3, that's going to be a -6x. I should have given myself some more room so I could draw my arrows better. All right, so inside 1 times x is a positive 1x. Okay, I won't write the 1 in the future, but I did for now. And a positive 1 times a -3 is a -3. All right, let's combine our like terms. So we're going to have our like terms are -6x plus x. So we have 2x squared. Negative 6 plus x is going to give us negative 5x minus 3 equals 0. I forgot that in the last one. So there is our quadratic equation. And is it in standard form? Remember, standard form is ax squared plus bx plus c equals 0. So yeah, it's in standard form. Very good. All right, let's have you try one. This one's a little harder. We're going to work through. Many equations with a degree higher than 2 can also be solved using the zero product property. Okay, so we've got 5x cubed plus 3x squared plus 14x. All right, again, we have this 14x over here. We don't want that. It has to be 0. So let's move that 14x. So let's subtract 14x. So then we have 5x cubed plus 3x squared minus 14x equals 0. All right. So do they have anything we can factor out right away? Absolutely, right? We could factor out an x. They all have x. So let's do that because it's not in standard form. So that'll help us. So that would give us 5x squared plus 3x minus 14 equals 0. That looks a little better. Okay, so now we have an a value of 5 and a c value of negative 14. And we want those two things to equal 3. So what is it going to be? Okay, sorry for that. I had to pause for a minute. Someone walked in. So picking up there, so we have 5 and negative 14. So 5 times negative 14 equals negative 70. Again, feel free to use a calculator to do some of these things, right? All right, and then we want a product whose sum is positive 3. So again, I'm experienced at this. You don't have to make the list out all the time of 1 and 70 and all that thing. But because I know 7 times 10, okay, is going to get me what I want. I just have to decide, or 7 and 10 are going to get me 3. But is it going to be negative 7 times a positive 10? Or is it going to be 7 and a negative 10? Which one gets me a positive 3 when I add them together? Okay, negative 7 times 10, or plus 10 is 3, where 7 plus negative 10 is going to equal negative 3. So the one I want is right here. Okay, so next up, I've got x and my quantity, so 5x squared. Remember, I split the middle. So since I have a 5 here, I want to group, personally, I want to go ahead and group my 10 with that. So I'm going to do 5x squared plus 10x. And then minus 7x minus 14 equals 0. All right, so my 5 and my 10 are grouped together, are going to be grouped together when I do my groupings, right? Because I have to group the first two terms together. And then negative 7 and negative 14 are grouped together because I know that they're common factors. Okay. So for a minute, we're going to leave, we can kind of like leave this x hanging. We won't mess with it for just a minute because we don't want to get confused. All right, so what is the greatest common factor between 5x squared and 10x? All right, it's going to be 5x. Very good. So 5x squared divided by 5x is x, plus 10x divided by 5x is 2. Negative 7x and negative 14 have a negative 7 in common. So that's going to leave us with x, negative 14 divided by negative 2, or negative 7, is a positive 2. All right, so we take out what we have in common, the x plus 2. What's left over? The 5x minus 7. And we have to bring down that x that we kind of got left out there. Okay, all this is equal to 0. All right, so we're doing really well. We've got it factored down at this point, but now we actually have to solve it. So that means we're setting each of those parts equal to 0. All right, so each of those parts. So we're going to take x. I was trying to get a different color. Didn't happen. So we're going to have x is equal to 0. That's that first one. Then x plus 2 equals 0. That's the second one. And then the last one. 5x plus 7 equals 0. So the first one's done. X equals 0. This one we would subtract 2. So x equals negative 2. That one's done. And then this one, we need to subtract 7. So we have 5x equals negative 7. Divide by 5. So x equals negative 7/5. So there's 3 solutions this time. Okay, so we might say solutions are 0, negative 7/5, and negative 2. Those are all 3 solutions. So there can be more than 2, oddly enough. All right, then let's look at example 6, that real world or real life application problem. So example 6, an engineer must increase the area of a launch pad by 75 feet. I don't know why I have a question mark there. It should be, oh, feet squared. Okay, I was like, why is that a question mark? What distance can be added to both the length and the width of the 10-foot by 12-foot pad to meet this requirement? Okay, so this part, right, it says what distance can be added to both the length and the width. So we have to add the same amount. So I've drawn this picture and shown our 10-foot by 12-foot launch pad, and then I've added a section of x dimension to both the length and the width. What would that make the length, right? If this is my length, it's always the longer side. My length should be these two added together. So the length would be 12 plus x. And my width, then, I have 10, and I had to add the x. So my width is 10 plus x. So then how about my area? This one's a little trickier, right? Area is typically length times width. Okay, so in this case, that would be the quantity, 12 plus x times 10 plus x. And I say it's tricky because it says we must increase the area of the launch pad by 75 feet. So this isn't the entire area. We have to increase, so that's plus. So it's these measurements plus 75. What do you think about that? Okay, maybe not so much, right? Hopefully you notice. That's not right because these would already have that increase in them. So when we're writing the area of this, it's not, what we wrote isn't helpful. Okay, we could say that it's either the length times the width of the new one is that quantity 12 plus x times the quantity 10 plus x, or that's also equal to 12 times 10, okay, plus 75. is our length times width, or our area. Let me write the area there. That's the area we have to have. Does that make sense? I hope I'm not confusing you. So both of those are correct. We just can't combine the 12 plus x and the 10 plus x with the 75. This is where the problem lies. All right. So the cool thing about this is, so let me scratch this all out here. We have both of these formulas for area. The second one down here is all numbers. There's not a single variable to it. We can actually solve it, right? 12 times 10 is 120 plus 75. That equals 195. So our new area has to be 195. Since we know that, we can say, well, hey, then this area, 12 plus the quantity 12 plus x times the quantity 10 plus x equals 195, right? It has to be the same. So now we can solve. You're like, what? How do we solve? Are we sure we can do that? Is that going to be helpful? What do you think? All right, well, the way we solve is let's start factoring this one. So we're going to take this 12 plus x, if I could write. Goodness. All right, so 12 plus x times 10 plus x equals 195. Okay, we're going to solve it just like we solve any other quadratic, but we've got to get it into that quadratic form. So we need to FOIL first. Okay, so 12 times 10, we've got 120. 12 times x, so plus 12x. Then we're going to do the inside. X times 10 is plus 10x, and then x times x is plus x squared equals 195. Definitely not in standard form. So we're going to start with our x squared. We're going to combine our like terms. So plus 22x and then plus 120 equals 195. Still not in standard form. Why is it not in standard form? Good, the 195 is problematic. So we have to subtract the 195 because we have to get 0 over there. So now we've got x squared plus 22x. 120 minus 195 is going to give us a negative 75 equals 0. Okay, so now we have it in quadratic form, but we still don't know what x equals. So oddly enough, we have to take this quadratic and factor it. Right? You're like, well, wait, we already had two binomials up here, 12 plus x and 10 plus x. We did, but it wasn't a factored binomial. It didn't help us, oddly enough. All right, so let's get back to work here. This one, right, x equals 1. So all we're looking at is the factors of negative 75 that add to be 22. All right, so since it's 22, I'm going to go with, think of 25 times 3. Right, 25 and 3. And I want it to be a positive 22, but I need a negative 75. So one of them has to be negative. So I'm going to do 25 and negative 3. That would give me, if I multiply it, would give me a negative 75. If I add it, it's going to give me a positive 22, which is what I'm looking for. Okay, so remember, bring this over here for a minute. I'm going to have x. We split that x squared up when there's x equals 1. X plus 25 times the quantity x minus 3 equals 0. Okay, so remember when, again, in the quadratic, when your x is 1, you just split it up like with x equal x and then your factors. And then you set each of those equal to 0. So x plus 25 equals 0, x minus 3 equals 0. So here x equals negative 25, and here x equals a positive 3. So the length and width should both be increased by, wait, can we increase by a negative 25? No, we cannot. So this is an answer, but it's not reasonable. We cannot increase it by negative 25. So our answer is here. Okay, the length and width should be increased by 3 feet. And lo and behold, that's what we got. So our measurements would be 15 by 13 if we did that. Okay. All right. I'm sure you are pressed for time today since that was 31 minutes of notes. So good luck on your homework tonight. And remember, you're just setting it equal to 0. Each part of that you're setting equal to 0. All right, I'll see you guys tomorrow.